and welcome back to a new video here on the Lötwig Fusel channel on my Boundless 2D game engine video series. Now in this video series we have currently implemented a bit of inversion of control inside of our code. So basically what we implemented is that you can get implementations and that you can register implementations of interfaces using a inversion of control container, a IOC stack. We called it a stack, but it's basically a certain type of IOC container to basically register implementations and to later on retrieve and instantiate them. Now in today's video what we want to implement is a bit of a more flexible module system. So currently our modules are just static libraries, which is good. They are already modular and we can compile them conditionally in theory, and we can of course also include them conditionally in our projects. But the big problem is that our registration is currently done out of the module. We have done this in our main, and basically what I want to do today is I want to move that line of code into the module itself. And of course, because this is how it shall work at a certain point, I also want to do that itself generates a bit more common. Now I want to start by defining myself a new project. I want to go into my source and I want to go into common, and I want to create a new package in here, or a new project in here, and call this one MSys module system. This is what I want to call that. I mean, the name is quite funny, but that's what I want to do. This is a module. It's called MSys. It's the module system. Let's quickly run mocks init here so that we initialize our project to the current state with the new project in there. And if this is finished, we have our MSys project and we can start coding. So if we reload everything, we don't need to save it. We should see inside of common, see our MSys module now, or our MSys library. This is all the common code or the common static libraries that do not work with our module system. Our module system is going to currently modules and the static library is the same. But what we want to do today is we want to kind of like move them apart. Now, basically what I want to have is I want to have an interface for modules in here. So we're going to have a imodule.h, and we're going to have a namespace BL2D, and I think like the container and stuff was directly in the BL2D namespace. This is kind of like the idea of common, right? Everything instead of common is inside the common namespace without like MSys and stuff like that. So basically we do want to write a very simple thing. So engine module is basically a module which implements interfaces. Later on, of course, the system could of course also be abused by games, right? By games, by the editor, by the runtime, they can all abuse this. So it's actually quite fine to create this as an imodule class in here. So how do we want to write an imodule? First of all, a imodule is going to be quite simple. I just going to have a destructor that's going to be default and it's going to be virtual. So virtual, so that we can have it like that. Virtual. No, there we go. So this is the basic idea, right? We're going to have it like that. Modules are going to follow a certain semantics. So what I want to have is I want to have a module description. We can move it into its own source file, right? So we can be 100% clear. So let's call this one module desk for module description. We could, of course, also write this out. Let's write it out. Description, like that. So that we are... Oh, no. Like that. Module description, so that we are 100% clean here. BL2D. I mean, these code files are gonna be quite simple, so we can do it like that. So struct module description. So how do we want to describe a module? Let's hashtag include a string in here. I do wanna use std string inside of here, and basically I'm just gonna add a module name for now, right? We can add later on more details to the module description, but for now I just want to have in the module name, I want to have a way of retrieving that. So let's include bl2d /common /msys /module description, and let's make a const module description reference get description, or get desk for get description, and let's make this virtual so that everything is good in here. So get desk is basically a way to get the module's description. Now this is one function that the module shall implement, and another one that the module shall implement is a virtual void register, and the register function is the function that shall register all of the IOC registrations. I think one thing that we're gonna do, even though this is not really required, we can include the IOC registrations here as a reference. This is a singleton, so we would not really require that because the IOC registration is a is basically a singleton, so it's kind of like pointless bringing this in here as a reference. However, if we at some point decide that we actually want to virtualize this even more and have multiple IOSG registration points, we could do it. This just gives us a bit more flexibility. We should just, for good measure, start and adding a bit of Doxygen code to that so that we later on could generate documentation out of that. Interface for engine for API implementation modules. And this is basically retrieves the modules description like that. They've probably mistyped this, and then here called when the module should set up its implementation. Alright, so IOC registration endpoint like that. Okay, and the return value of that is const ref to descriptor. Alright, so this is basically the base class that we want to implement for all of our modules. And later on, the MSys, the module system, is also going to contain a module loader that is going to be responsible for loading all the modules that are in here. So what do we want to do next? So the next thing that we want to do is we want to add a new item in here to be able to do dummy. So we actually want to write a dummy module. So I want to call this dummy module. And the general idea is that we have a capitalized D for the kind of like package name, and then we have the suffix for the module. We could also maybe imply a different semantics so that better matches the name. I want to auto-generate later on stuff, so this shall match this completely. Maybe we're just gonna name it the same like the package. This is maybe a good idea. bl2d.dummy.h. This is, I think, a good naming convention. That will keep the name of the module and the class that actually implements the module the same. This might be a good idea. So namespace, I do want to put this in the global namespace. No, I don't want it. I want to put this into bl2d modules. Inside of bl2d modules, this is the class where everything shall be in here. And now I basically want to have a bl2d underscore dummy. So now in the class name, because the class name can't hold a dot, this doesn't work, I want to have an underscore. Maybe we should already have the underscore here in the file name to make this a bit more... No, I don't like it. I want to have the name as is in the header. And the class is replaced with underscores. So module bl2d dummy. And this is a public module. So now we need to, of course, include the module. So bl2d common MSys module. So now we can implement this module, which is a bl2d module. And now we can start and implement the features in here. All right, so the first thing that I want to do is create a source file for that module. I mean, we would not really need to, but I would recommend that so that we don't have recompiles if registrations change. That's the general idea. And now I can implement the virtual methods. Let's keep them both in here so that we get them like that. We don't really need some commenting here because it's already, the API is already documented and we don't need doc annotations for every module. This can be always as simple as that. In the future, we might also apply some mechanisms to at least generate the header. Maybe not the CPP file, generate a header. I'm not quite sure how we can do this with Premake. If we can check if a file exists, and if it's not existing, we might be able to create that. That might be something that we can think of later if we can do an automatic module generation there. All right, so how do we do the description? So module description D, I can do a static static const module description, and basically just set this all up as is, so I can provide a name in here and provide the name as bl2d.dummy, and maybe we want to additionally to the name have a display name, and maybe we want to have a description. Maybe we're gonna have a package name, a display name, and a description, so that we have a bit of more things in here. So we have the package name, we have the display name, which is dummy, and then we have the description, and the description is a simple codeless module, a simple hello world module, so that we can quickly check if stuff is working. Now, what's a bit more interesting is the register function, because basically what we want to do is we want to move that into the registration function. I am always lazy, so I'm basically going to copy these two lines, and then I can basically paste them in here. And the general idea is that we have the includes of the actual implementation. So put implementations here. Implementation includes here. So that basically all includes are put up there. And then put implementation registers here. So this is basically the syntax that I want to apply, how this works. But what I don't want to do is don't want to go over that. I want to go over the registrar that has been supplied to that function. That's the idea. And this is in theory now a template that we could roll out every time a module is created and the file does not exist. This is something that we could already try implementing in Premake, right? So that we can do this side by side and hand by hand. So in Premake, if I go into my boundless 2D, instead of scripts, basically what we had is we had a project, and we basically had a module. And the module was basically the same than a lib. But what I now want to maybe do is generate module main files. And this is something that we might want to be able to do. I do need to find out if we can do this with Premake. I think Premake 5 does have a few functions for file operations. So there's like a reference, and there is IO write file name and content. And there is, I think, a OS. Maybe there's a OS exist. OS RMD, remove real path. Not quite sure. OS locate is file. Yeah, I think OS is file is something that we can use. So for now, let's quickly try OS is file. So if OS is file and OS is OS is file, is there can I do? I think I can do that. Not true. Then print generate. So this is kind of like the idea that I want to have. We can have a quick. Let's do and add a quick module in here so that we can try that out. If I create a new folder and just call this mod x1 for a simple module, and just copy the build file over and call this one mod.x1, I think this one should now give me a generate. So terminal. Let's open up a new terminal here, and let's do a mox init again. Then I hopefully get a unexpected symbol. How did I equals false? I'm not quite sure. Do I need to do double equal in Lua ifs? I haven't used Lua in a while. Bad argument to. Okay, of course. Of course, I need to provide a path. Let's say, what is actually / currently? I think we are. Let's see, / I have a name. .h. Let's see what this gives me. Generate. This gives me a generate, and then let's quickly try out if we are on generate, if we can generate this file with OS or IO write file. IO write file. So let's quickly try that out. Let's call this one local mod header. And then we check if it is a file, and if it is a file, I say hello to quickly just write that file. And let's see where we got that file. I mean, we should get it somewhere. The question is, what was our current working directory? Okay, it was at the current build.h. So we now have generated the mod.h file. Maybe we gonna do another print here and say hell or something like that. We should not get this HAL now, because basically the file already existed. If I do true, however, is it gonna append to that file? So if I now go in here, no, it's always overwriting the content. All right, so this is a good thing that we have. All right, so module header, name, and now we have the content. Now, I think we should be able to basically read this with IO read file. And if I say IO read file, I should be able to read in a template and then write it, right? So let's create a folder, templates, and let's create a new file in here. And let's call this one module underscore header.h, or let's create a new folder, module Lua module. So this is a Lua template for a module. So what I want to call this one now is module.h. This is kind of like the template. I now have IO read file, that's not a problem. Module.h, and then we're gonna have a module.cpp. And what I want to do is I basically want to generate these from the template that we just have implemented. Now the module should be in here, which isn't the big deal. Let's wait until it's in here. This has a problem now. Damn. Of course, this is also has now overwritten that. That's a pity. I don't think that I can get that data back. Yeah, because I basically put the file check out of there. This is not nice, but this is what happens if you're doing stuff. Class BL2D dummy public iModule. Let's hashtag include BL2D / common / emsys / iModule. Let's peek the definition, or let's go to it. I don't really care. I'm just gonna paste them in normally because I don't know if it really works. Public. Did I actually make the interface public? Yeah, I did. Sometimes I forget things like that. Let's then go and override these. We should make the code working again. Yeah. And then basically I want to copy all that code and put it in my template header. Now the only thing that's now a problem is the actual name. So you can see that this name should of course be replaced. So I don't know how string replacement in Lua works, but I think I can just do it. So how do I want to do it? Let's do it with these brackets. I think this is a bit more. And let's call this one name dash, or name US for name underscore. This is kind of like the current package name as a underscore. And inside of module.cpp, we need to copy the other file in here. And basically inside of module.cpp, we have the name US, which is the name with underscores, which of course goes in here. This is the name with underscore. This is the name with dot. The implementation, of course, is not in here, and the registration is not in here in the template. BL2D dummy is the name with underscore. Name with underscore module descriptions is all fine. Now this is the module, the name with DT, so the name with dots. The display name is just gonna be the same, so we just gonna provide a template like that. Now name with dots is to include, of course, name with dot.h, so that we can include it. And this is now basically the template that I wanna apply. Now, basically what I wanna do is I wanna write a bit of code that can generate that. So currently you can see that we have these project template functions, and now I wanna have the file generation functions here. So file generation is a very simple one. The first one that I want to do is replace patterns, and then we're gonna have content and patterns. So basically this function shall replace in string. So let's quickly find this out. Lua replace string. Lua string replace. Alright, so gsub can I replace gsub s pattern replace? Hello Lua user. It's a very function that can be used in multiple ways. Using simply it can replace all instances of the pattern provided with the replacement. Okay. So string gsub string. So this I think should work, gsub. And then I need to replace the pattern and the replacement. 4 kv in I pairs, I think, of patterns. Do and content equals content gsub kv. This I think should work. Let's maybe try this out with a Lua online shell. Lua shell. Oh, come on, online. Do we have a Lua online shell? Yeah, tutorials point. I don't really care about what happens here. If I now maybe call this with print and replace pattern. Maybe I should zoom in for you. Replace pattern. And I quickly do a lol and then a b. And then I do the pattern. I don't know. How can I Lua table? I'm not a really a professional in how to do proper Lua tables. I can do a table and then I can assign them like this. So maybe let's do it like that quickly. Where's my online shell? There's my online shell. Let's do this like that and call this P for the pattern table. And then I have my A, which I want to replace with 1. And then I will have my B that I want to replace by that. And then I can put in my patterns, and this hopefully now executes without problems. Okay, this Lua shell is broken. Lua, yeah, let's do the proper Lua demo. Expected near. Input line 4, 1, 2, 3, 4. Expected near, Klammer auf, content gsub. We can do string.gsub for content. Your program ran successfully and I didn't get an output. Interesting. Let's debug this if I can get this working. Print k. Okay, this Lua shell seems to not even work as well. Or let's quickly see if this works here, the template of these. Result, yeah. It's not really executing something. For KV and E pairs. Ah, maybe I need to do it like that because E pairs is like integer pairs. Can this be a problem? Okay, yeah, this can be a problem. So the keys is actually printed, but not my result. Okay, why is my result not printed? Print content. A lol2, 1 lol2, and why did it not replay? Oh, of course, return content. Needs to, of course, be returned, otherwise it can't print that, because it's printing a nil value. 1 lol2. Okay, so this is basically how the replace function should work, and there we have it. This is how you do professional engineering, right? So replace pattern now works. Now what I want to do is I want to have a function generate header. Now the generate header function shall generate a name, shall give a name and then generate a header file, and generate file. I want to generate a file which is basically the out file, template, and patterns. This is what I want to have. I want to have an output file, I want to have a templates, and I want to have pattern. I want to have patterns. And this is only, this is, I think, should always generate a file, right? And then the if statement should be somewhere else. Alright, so I'm gonna say content equals IO read file template. So I'm gonna read that and then I'm gonna print that. So this is now what I wanna quickly verify. And then I'm gonna write, let's make a function generate header on demand. So this is generating a header on demand, and this is gonna be the package name, right? Okay, so this is basically what I want to call instead of that. Generate header on demand. And what I want to do in here is I want to do that. Gonna call this one header, which is the name.h. And if this is not a file, it will generate a file. It will generate a file for that out file. Of course, this also now needs to be header, right? Patterns equals that, and my patterns for the header are name. This is gonna be name dt for the dotted name. Patterns name us underscore equals string gsub name, and then I want to replace dots with underscores. But this doesn't work. I know that this doesn't work because a dot is a special character in that gsub statement. And therefore we need to do something different. In a second, I'm currently in the modules directory. Now I am one up. 1 second. I am inside of that one, module X. So I'm going to go one up inside of modules. So I'm going to go into another one up. I'm BL2D. I got one up. I'm in source. I've got another one up. I'm in the root directory. And then I go into templates. This is not really nice. Lua module. Module.h. This is the general idea, right? This is how it should work. And now I quickly should see the content of the header, right? If it's gonna get generated, but I'm not gonna get that. Local name, okay. What? Generate header on demand, name, local header, name, what? Line 35, local header. Okay, I did not provide the name, of course. Of course, I need to provide the name here. Yeah, that's the problem. Let's call in it, and then it should be going well. Of course, it's not doing anything because the header is currently in existence. So if I delete the header, then I should get output back. And what do I get? I basically get my exact header. Okay, so I actually get the content. That looks good. I'm not quite sure what that is. I think it's hopefully a normal string. So what I now want to do is I now want to replace patterns in my content. So content is read file, then content is going to be replaced with the patterns. And then I can write file to my out file with my content. That's the idea. Right? Let's try out if this works. It regenerated a hell a lot of stuff. Did it change the hell a lot of stuff? No. The header has not been correctly initialized, however. But this is actually, I think, fine because we need to fix the gsub, right? And one thing that I have forgotten is I've forgotten to add these. This is the pattern that I need to provide. Generate header on demand. Now, generate H or PP. H or CPP on demand. And ending. Actually, my ending is going to be H or CPP. I can actually supply that. I can use just a F in here. Local ename. No, it's okay. I'm just an idiot. Module is of course okay. And then the ending. This is how I need to do that because it's the same template, it's just that it's H or it's PP. And then I can generate these by calling H, of course with the proper file, with the proper function name. Of course, it's generate module H or CPP on demand. This is the function that I want to call. Or this is how I want to call the function. And then I can do this for H. And I can do it for CPP. And then it should generate these. Now the only thing is the gsub. That's still a problem. Because basically dot means any character, and this is replacing any character with an underscore, because it's like regex. And I think we need to do that. Not quite sure, however, how Lua was doing that, but this should be in libmox.lua. Ah, it was a single dot. All right. But yeah. Gsub. We don't have a gsub in here. Then it is in... Right, it needs to be in... I have generated underscores previously, but I don't know which project. It's not in here. Okay, then it's not in here. I hope it still works though. tcpp mod.x1. So this didn't work. You can see that mod.x1.h works, but this one is not generated properly. Okay, let's go to good old ChatGPT. Please write a Lua code that replaces every dot with underscore in a string using gsub. Okay, so it was percentage. Okay, percentage is the escape string. That's okay. So we're gonna use percentage, not backslash. It's percentage then. Okay. If we do that, it should not change anything at all, right? Because the files exist, and if the files exist, it's not gonna change them. However, if we go into stories, module, mod x, and if we are quickly deleting these and rerunning these, it should generate these. If I now take a look at these, we should have this mod underscore x. And we should have them with mod underscore x, with mod dot x underscore mod dot x. Okay, so now this works. Now we can delete that whole shit. We don't need it anymore. And we have boilerplate code for generating these module files. Now this took way too long. I didn't want to really do multiple videos on these. Maybe we can get it running fast. Yeah, the operation cannot be completed. Remove. Yeah, remove it. It's okay. And now I think we should be good. Now we have a bit of a way of generating these files. Now this is good. Now we have a module, but the module, of course, is not loaded automatically. Maybe we do want to move this into another video, because we are quite far currently. Okay, so I think we're going to move the rest of this into the next video. I mean, no, not just yet. Okay, one more thing. I have the implementation, and now I want to have the module in here. So let me quickly, I do want to do that. Go to the BL2D dummy module, and let's include the modules header, and let's have a BL2D modules, BL2D dummy, mod dummy. So I'm gonna have the mod dummy module, and then I can call the register on BL2D ILG registrations get. And then I think the registration should work, because if I would not have this register, this code would fail because I can't find that, right? It has a problem in general. Must return a value. Oh yeah, return desk. That's also something that needs in the template, of course, that I need to return the description. Let's go into my templates in the CPP file. Let's paste this in here so that the template is up to date. All right, so if I start that, we get a failed because we can't run a library, which is correct. So set this as a startup project. I don't know why it lost that, but yeah. Unsuccessful build. msys.lib. Cannot open file msys.lib because this msys is currently not containing CPP stuff. This is something that I love. Dummy.cpp. And as soon as there's a CPP file, even if it's empty, it's gonna generate a library file. Ooh, amazing. Yeah, because then now it has basically an object code. Now you can see that we get a problem that my dummy was null pointer, because basically all the dummies are null pointer because no implementation has been registered for these, which is exactly as expected. And if I register the module, it should register itself. And then you can see it works, and we do get our Hello World implementation. All right, that's good. So actually I wanted to do this in one video. Let's do it in 2 videos. So this video was a bit about me not knowing Lua. But this is okay, because it's a game engine series where we want to do everything in a hands-on tutorial-based series. So thanks for watching. See you in the next video, where we're going to write a module loader that's doing all of that automatically for us. Then have a nice day. See you in the next one. Bye.